To carry a 100-pound cylindrical weight, two people lift on the ends of short ropes that are tied to an eyelet on the top center of the cylinder. Each rope makes a 20-degree angle with the vertical. Draw a diagram that gives a visual representation of the problem. Then, find the tension in pounds in the ropes. Here is a diagram of the cylinder, the eyelet, and the ropes. You know each rope makes a 20-degree angle with the vertical. Now, draw two right triangles between the ropes to solve the problem. Using these triangles, you can find the x component of the tension in the ropes and the y component of the tension in the ropes. Let's use vectors to represent each rope. Call rope 1 vector u. The x component of vector u is cosine of 70 degrees, and the y component of vector u is negative sine of 70 degrees. So vector u is equal to the magnitude of vector u times the quantity cosine of 70 degrees I hat minus sine of 70 degrees j hat. The rope on the left side is rope 2. Let's represent this rope with the vector v. The magnitude of the tension in each rope is the same, so you can use the magnitude of vector u in equation 2. The x component of the rope on the left side is negative cosine of 70 degrees, and the y component of the rope on the left side is negative sine of 70 degrees. So vector v is equal to the magnitude of vector u times the quantity negative cosine of 70 degrees I hat minus sine of 70 degrees j hat. To find the tension in the ropes, you want to find the value of the magnitude of vector u. So notice that the forces pulling down on the cylinder must equal the forces pulling up on the cylinder. So since the cylinder weighs 100 pounds is pulling down on the cylinder, and the y component of the ropes is pulling up on the cylinder. So add vector u and vector v and set it equal to negative 100 pounds since 100 pounds is pulling down on the cylinder. Substitute for vector u and vector v and simplify. You are left with the negative magnitude of vector u times sine of 70 degrees j hat minus the magnitude of vector u times sine of 70 degrees j hat equals negative 100. Simplify and you find the magnitude of vector u is approximately equal to 53 2/10. Therefore, the tension of each rope is approximately 53 2/10 pounds.